Hello, good afternoon, everyone. In continuation with the last lecture, where we have discussed about the use of machine gun formula for the signal flow graph. Here is one of the example where you can see a signal flow graph of any system is given, where the gains nodes are specified within the bracket, within round circle, that's A, B, C, D, E, F. We see these are all these nodes, and these are the branch gains, and signals are moving in different directions are used. That means the branch arrows with the branch gain indicates the flowing of the signal from one direction to another direction. So here we will start find out how to get your CYR. So this is our motto by using the machine gain formula. We know already about the machine gain formula. Now it is bit easier for us. So first of all, what you have to find out, number of forward path, that is K. What is this? You see, try to find out this arrow directed from R to C. So this is one forward path, as you see. Next, you see here you move from there and go there. So this could be one forward path. So definitely there will be two forward paths. And once we get k is equal to 2, so t is equal to becomes 1 by delta summation k pk delta k, right? So we get delta p1 delta 1 plus p2 delta 2. So what is p1? Next is to find out p1, that is the first forward path gain, right? This is first forward path gain. So first forward path gain means this is 1 into g1 into g2 into g3 into g6 into 1 into 1, right? This is the first forward path. So gain is g1, g2, g3 and g6. Okay, next we have to find out the second forward path gain. What is the second forward path gain? Second forward path gain means 1 into g1 into g5 into 1 into 1. That means only this will be g1 and g5. These are the two forward paths with two forward path gain, right? Next step was to find out the value of that is number of individual loops. Okay, so how many loops are there? Loops means originating and terminating points in the same without traversing a single node twice. I am repeating, without traversing a single node twice, right? So you see here we will find the loops like you see this is one loop, right? B, C and B, the directed in this direction. So this could be the loop 1, and you see this is a loop 1 with loop gain. What is the loop gain? This is G1 into minus of H1. So minus of G1 H1. This is the loop 1 with gain L1. Similarly, you see this is a simple one loop. This is L2. So we found the second loop, right, with gain G2 into minus of H2, that is minus G2 into H2. That is another loop with loop gain we found, and obviously this is the same loop. Already we know this, we might call it as L3, that is minus H4. So this is another loop, and you see is there any other loop? No, this is going in this direction, so this is not in backward direction, so loop formation is not possible here. You see this signal is going from B to C to D to E and coming back to B, right? So this can be L4, right? So we may call L4 equal to, so G1, you see, G2, G3 and minus H3, right? This is another loop. And is there any loop form possible? No, no, no. I found out no more loops here. So there are 4 individual loops. Like, so once you get the 4 individual loops, Next step is to find out whether they are non-touching in nature or not. That means two possible combinations we have to find. That is, what is this? So L1 L2, this can be the combinations. Is it possible to find out L1 L2 non-touching combinations? So next, non-touching combinations. So L1 and L2. See, L1 and L2. L1 here, L2 here. So there is no common node sharing. Okay. So L1 L2 is the combinations that is possible here. So we can write number one possible combinations L1 and L2. So L1 L2 with the possible combinations, the gain products will be equal to L1 into L2. So G1, G2, H1 and H2. Next, L1 and L3. Yes, L1 is there and L3 is there. They are not sharing the common nodes. They are not sharing the common nodes. So L1, L3 maybe second combinations. So if L1, L3 with the combinations, then the gain products will be equal to the products L1 and L3. That means G1, H1 into H4, right? And next, L1 and L4. L1 and L4. See, L1 is this, L4 is this. So they are sharing the common node. So L1, L4 is not possible, not equal to non-touching loop. So this is not valid. Okay. Next, you see L2, L4. If L4 is this and L2 is this, so L2 and L4, this combinations is not possible, right? So next, it can be L3, L4, right? So L3 is there and L4 is there. So L3, L4, there is not common sharing node. That means there is a branching in G6. So these nodes are separated. So they are not sharing the common node. Definitely L3 and L4 will be another combinations, right? So gain products will be L3 and L4. You see this G1, G2, G3, H3 and H4. So we get all the data like number of forward path. If number of forward paths we obtained, so corresponding to that we obtained the forward path gain. Once you get forward path, so the formula will be modified like this: 1 by delta P1 delta 1 plus P2 delta 2. So P1 P2 already obtained. And next, to find out the delta, so delta is a function of basically loop gains. So in that case, you have to find out the number of individual loops. You see there are the loops. I have already written in other colors to mark it. So L1, L2, L3, L4, there are 4 individual loops with loop gains. Loop gains means the branch which consists used to find actually construct the loop. This is G1 into minus H1. So minus G1 H1 is the loop gain like this. And next is to find out non-touching combinations. That is two non-touching combinations. Better tell it, two non-touching combinations. So L1 and L2 common node sharing is not there. L1 and L4 common net sharing is there. L2 and L4 there is a common node sharing. L2 and L3 no common node sharing. L1 and L3 no common node sharing. L3 and L4 no common node sharing, right? So once this obtained, next is to find out three non-touching combinations. Three non-touching combinations means either this L1, L2, L3, maybe one combination. So L1, L2 and L3. See, there is a combination available, first class. So you get L1, L2 and L3. If you consider these three loops at the same time, so you get this L1, L2 and L3. And L1, L2, L3, they are not sharing common node anymore. So L1, L2, L3 is a combination. So you see, this is L1, L2 and L3. So if you multiply this, you will get the gain products. So this is minus G1, G2, H1, H2, H4. This is L1, L2, L3. Next, what could be the combinations? L1, L4, L3. L1, L4, L3 is not possible. L1, L4, L3. L1, L4 is common node sharing. So L2, L4, L3. L2 and L4 sharing the common node, so L2 L4 L3 is not possible. And next, what could it be? L1 L2 L3 is possible. L1 L2 L3 L3 L4. So L1 L2 L4 L1 L2 and L1 L2 L4, they are sharing common node. L1 L2 L3 L4. Next L2 L3 L4. L2 L3 L4, that is not possible because L2 and L4 common sharing is there, right? So we will be having only three non-touching loops combinations, L1 L2 L3. So this is having the value of gain product. So now all the values we have obtained. Once we get all these values, now what you have to find out next is that the value of delta, right? So we will write the value of delta here, maybe in these positions. So we write delta, okay, delta is equal to 1 minus L1 plus L2 plus L3 plus L4 loop gains of all individual loops plus all possible combinations of two non-touching loops. That means we can write three possible combinations, L1 L2 plus L1 L3 plus L3 L4, okay, minus three possible combinations. There is a one combinations by which we can get L1 L2 and L3. So this is your delta. Now if you put this value of L1 L2 like minus G1 H1 and all these things that I am not putting here, this is actually L1. So you get the value of delta. Once you get the value of delta, definitely from there you will find out the value of delta 1 and value of delta 2, right? And these values you have already noted, P1, P2, L1, L2, L3, L4 and all these things. So next is to find out the value of delta 1 and value of delta 2, right? I'm just removing this part. So but you have to find out delta 1. What does it mean? Delta 1 means actually that part of the delta which is in not touch with. That means you have to first find out the fast forward path. This is your fast forward path. See, and whether it is touching any loop or not. See, fast forward path is touched with L1. So touching, we will write touching loops. Fast forward path touching loops L1, it is touching L1, it is touching L2, it is touching L3 and it is touching L4, right? That means fast forward path touching the loops L1, L2, L3, L4. That means L1 will be 0, L2 will be 0, L3 will be 0 and L4 will be 0. So definitely all the terms will be 0 and you will get delta 1 is equal to 1, right? Similarly, if you just go for the second part, that means the delta 2, we have to find out the delta 2 and you see the value of delta 2 is equal to, that means we can write second forward path touching loops. Which are the loops actually second forward path is touching? See, second forward path here, there and finally goes there. So second forward path is touching L1, that is touching these sections. This is going there, that means this is touching L3 and also this is your L4, so this is touching L4, right? But this second forward path is not touching this L2 part, right? This is the L2 part which is not in touch with the second forward path. So the value of L2 will be only valid. this will be 0, this will be 0, and this will be 0. Once you get like this, the value of L2 is known to you. What is the value of L2? So L2 is equal to, you know, from this minus G3 is 2. So what will be the value of delta 2 then? This is 1 minus L1 is 0, L3 is 0, L4 is 0, right? So only this general formula will be L2, and as this L1 is 0, so L1 L2 will be 0, L1 is 0, L1 L3 is 0, L3 L4 is also 0 because L3 L4 are 0, and L1 L2 L3, these three are also 0. So only 1 minus L2, that means 1 plus this will be G3 is 2. So you get delta 1 and delta 2. Now all the parameters you have obtained. So Q will be equal to 1 by delta, put the value of delta here. L1, L2, L3, L4 and all these values are known to you. We just put here in the denominator. Next P1, fast forward path gain, you know, put here. Delta 1 is 1 here, plus P2, second forward path gain, you know, you put there, and put the value of delta 2, that is this, right? So this is the overall transfer function. That means C1 R for this type of you know, this call it signal flow graph, right? So what you have learned how to find out the defined path gains, how to find out the defined forward paths, and next the different individual loops, and whether the loops are formed. There may be two possible combinations of non-touching loops, that means whether they are sharing any common node or not, and if there is any possible combination of three possible combinations of non-touching loops, that means the three different loops which are not in touch with any common node. So that is your the possible combination of three non-touching loops. And finally the value of delta. Whenever you will find out this value of delta, next check whether this loop is in touch with the forward path, first forward path, second forward path, and third forward path, and so on. So according to that, if the loop is in touch with that, remove that value, add or make that value is equal to 0. Otherwise the value of the loop gain you will find out from the signal flow graph, and put the value to find out this overall transfer functions, right? So in the next lecture we will concentrate on the time response analysis of systems. That means just a brief introduction. I will say, we know what is your system, like you know, this is your RS. This will be discussed in detail in the next series of lectures. So basically what happens, this is RS, this is GS, and this is CS, as you know. Now this RS means basically in time domain this is your RT, and this is your plant or system to get your CT. So this is a function of time, and this is a function of time, because in every nature, the nature, everything is continuous function of time. So basically for time domain analysis, what we see, different kinds of signals are used as test signals, and these test signals are used to pass through any system to get certain kind of output which is function of time again, and how the system is behaving with the changing of the input signal with respect to time. So that behavior is known as the time response analysis, and in details what kind of signals are used as the input, and how to get the output from any type of system, maybe first order, maybe second order, maybe third order. Already you know this third order, first order, second order types, and type 0, type 1, type 2 systems, and their behavior. And you know the two terms like transient response parameters behavior and steady state behavior also. So transient response behavior and steady state response behavior, and how to get the perfect desired output, that means error free output you can generate. So that will be in detail analyzed in the next series of lectures, that is time response analysis. Okay, thank you.